Welcome everyone. Let's begin our lesson for today by going over the learning goals and success criteria. First, what are we learning? We're learning how to select the most efficient method of finding a solution to a system of linear equations, how to find the slope and y-intercept of a function from an equation, how to graph linear functions using slope and y-intercept, how to graph multiple linear functions on the same plane and find the point of intersection, how to solve systems of equations algebraically using elimination method, how to solve systems of equations algebraically using the substitution method, how to recognize patterns in the graphs of systems of linear inequalities, to determine how to find the overlap of the shading of a system of linear inequalities, to graph linear inequalities using slope and y-intercept, to use the correct line and shading for the graphs of inequalities, and how to graph multiple linear inequalities on the same plane and find their intersection. How are we learning it? Through the Systems of Linear Equations and Inequalities Review Part 2 notes and the Systems of Linear Equations and Inequalities Review Part 2 assignment. When can we use this information? To calculate the amount of money in a savings account, to find economic solutions to financial problems such as income versus expenses and supply versus demand, how to run a successful company by recognizing and utilizing the principles of supply and demand, to determine the best way to complete a task when there are multiple ways to complete the task, such as putting up a new fence in the backyard, how to run a successful business by understanding the principles of supply and demand and production costs, to determine which scores you can receive on your final exam that will allow you to pass the course, and to determine how many of each kind of product you might need to sell to reach a goal profit. How do you know you learned it? By getting a score of 4 on the Systems of Linear Equations and Inequalities Review Part 2 assignment. Now let's take a look at our agenda for today. We will begin by going over the learning goals and success criteria. While we do that, you'll fill out your Get It Started. Once you've completed your Get It Started, we'll go over it together and answer any questions that you may have. After that, we'll go over the Systems of Linear Equations and Inequalities Review Part 2 notes, and then I'll give you time to complete the Systems of Linear Equations and Inequalities Review Part 2 assignment. Once you've completed the assignment, we'll go over it together and answer any questions that you may have. At the end of class, we'll go back over our learning goals and success criteria while you fill out your Before You Go. Your only homework for tonight is to work on any incomplete assignments that you may have. Let's take a look now at the Systems of Linear Equations and Inequalities Review Part 2 notes. The notes begin with the learning goals and success criteria. Now let's talk about slope. What is slope? Slope is a rate of change involving x values and y values. Slope is known as for being the change in the dependent variable over the change in the independent variable. Now what does that really mean? That really means that slope is the change in the y values over the change in the x values. So it's always y over x. And the next part you need to know is the y-intercept. The y-intercept is the point where the linear function crosses the y-axis. So we have a line here, and we can see that the y-axis goes here. So where do they intersect? Well, they intersect right there. That is what we call the y-intercept. So in this case, our y-intercept would be 2. Slope-intercept form. Slope-intercept form is written as y equals mx plus b. And what does that mean? M is the slope, and b is the y-intercept. Y and x are my variables that stay variables so that I can plug numbers in and see what they come out to be. So m is the slope and b is the y-intercept. Now how can I remember that? The easiest way I remember this is m represents the slope because it's a slippery slope to get hung up on your x. So think about it in terms of relationships. People that are involved in relationships and they break up, there's usually that one person in that relationship that's always hanging on to the relationship that's already dead. That's the slope. That's M. It's a slippery slope to get hung up on your ex. They are not together anymore. But the M is always trying to hang on. Notice how close they are. So M is trying to hang on, and it's a slippery slope to get hung up on your ex. Now B, on the other hand, is alone. Not attached to anybody. B is lonely. And lonely people ask the questions, why am I alone? Why does no one want me? Why does no one think I'm cute? That's B. B is always asking the why questions. Those are the y-intercept questions. So that's the way I remember it. It's a slippery slope to get hung up on your x, and y am I alone. So that's the way I remember slope and y-intercept. Now, let's go ahead and pick out the slope and y-intercept from an equation. So we're given an equation, y equals 2x plus 4. And we want to know what is the slope of that line. Well, we know that the slope is the one that's attached to its x, right? So it's a slippery slope to get hung up on your x. So the one that's attached to the x in this case is 2. So the slope is 2. The y-intercept is the lonely one. Why am I alone? Well, the lonely one is 4. So my y-intercept is 4. So that's how I pick out the slope and y-intercept given an equation. Let's look at another example. We have y equals negative 3 halves x minus 3. Well, same thing. It's a slippery slope to get hung up on your x. So the slope is the one that's attached to the x, which is negative 3 halves. So that's my slope. And my y-intercept is the lonely one. Well, the lonely one in this case is negative 3. So b is negative 3. So that's how I find the slope and y-intercept from an equation. Now, how do I graph a linear function? Well, first thing I need to do is pick out my slope and my y-intercept. Well, in this case, my slope is negative 1/2, because that's attached to the x. Now, my y-intercept, notice there's nothing here. There's no lonely people. So how do I say none in math terms? Well, that's 0. So my y-intercept is 0. So now when I graph this, the first step is I plot the y-intercept. Well, my y-intercept is 0. So I'm going to go along my y-axis and find 0, which is right here. And I plot my point. The next step is I'm going to use the slope to plot my second point. Remember, this is change in y over change in x, or you might have heard it in the past as rise over run. We're going to talk about it as change in y over change in x. So my change in y is negative 1. So I go down 1. And my change in x is 2, so I'm going to go to the right, 1, 2, and plot my point. So now I have my first 2 points. The next step is just to connect the dots and draw a line between them. So I'm going to connect the dots, and now I have a linear function that is graphed that goes through 0 and has a slope of negative 1/2. There's a video here also that shows you how to graph linear functions in Desmos. So you can go ahead and watch that. Let's talk now about how to check our work with linear equations using Desmos. So what we're going to do is we're going to go to desmos.com, just like this, and we're going to click on the link that says Graphing Calculator. And over here on the left side, we can enter the equation of any linear equation and it will graph it for us. So let's try y equals 2x minus 4. Well, as we can see, it graphs it for us. We can check that against whatever we did on our assignment now. And you can do it this way. Let's say we had an equation, though, that wasn't in slope-intercept form. We can still graph that on here and check our work. So let's say it was 4x minus 2y is equal to 8. And we can see that that's actually the same as this one. But we can look at this and check our work this way as well. It still graphed the equation in slope-intercept form, even though the equation we put in is not in slope-intercept form. So this is one way that you can check your work using Desmos to find linear equations. Now, how do we determine the correct method? So first of all, we need to discuss what methods we have to solve systems of equations. So the first one is graphing. Now, graphing works best if the functions are already in slope-intercept form. We don't like putting things into slope-intercept form. So if they're not in slope-intercept form, then let's use a different technique. But if they are in slope-intercept form, graphing is a great way to go. So this is usually best when both functions are already in slope-intercept form. And that looks like y equals mx plus b. Substitution is our second method. Substitution usually works best if one of the variables is already isolated. So we have y equals something or x equals something. So if one of those is isolated already, then we can just take that value and just plug it in. So substitution usually works best if one of the variables is already isolated. For instance, x equals my plus b. And lastly, we have elimination. Elimination usually works best if the equations are written in standard form, meaning the x and y's are on the same side. And that looks something like this. mx plus ny is equal to b. So this is how we can determine which method is the best version of what we need to do. Now let's take a look at how we can graph systems of linear equations. So all this really means is we're going to graph both of these lines at the same time. So on the first one, we'll go ahead and graph this. So we're going to plot our y-intercept, which is -2. So we're going to go down 2 and plot our point. And the slope is 1/3. So we're going to go up 1 to the right 3, plot our point, and connect the dots. So just like we did earlier, that's the same thing we're going to do now. Now, we're just going to plot the second line on the same graph. So my y-intercept for this one is 3. So I'm going to go up 3 and plot my point. And my slope is -1/2, so I'm going to go down 1 to the right 2, connect the dots, and notice now I have a point where they intersect, which is right there. That is considered the solution to the system of equations. Now let's talk about how we can solve these systems using substitution. So we have two equations here, y equals 2x minus 3, and x plus y is equal to 6. So the first thing we're going to do is isolate one of the variables, which means we're going to get one of the variables by itself on one side of the equal sign. Well, the nice thing is we already have that right here. We have y isolated. So we know that y is the same thing as 2x minus 3. So what I'm going to do is I'm going to plug in the value on the other side for y into the other equation. So I have x plus y is equal to 6, but y is really equal to 2x minus 3. So I'm going to plug that in. So now it says x plus 2y minus 3 is equal to 6. Now I can solve for x. So I combine like terms. I get x plus 2x is 3x. So I have 3x minus 3 is equal to 6. Then I'm going to add 3 to both sides. And I get 3x is equal to 6 plus 3 is 9. Now I can divide both sides by 3 to get x by itself. And I get x equals 9 divided by 3 is 3. So there's my x. So that's the x coordinate of where they cross. Now I need to find the y coordinate. So I'm going to plug it into one of the equations. It doesn't matter which one. I'll use this one, x plus y equals 6. But x is really 3, so I'm going to plug in 3 for x and then solve for y. So I'm going to subtract 3 from both sides, and I get y is equal to 6 minus 3 is 3. So when x is 3, y is 3, and that's the solution for both of the equations. Now what happens if the variable is not already isolated? So that's our goal, is to get one of the variables isolated. Now if they're not isolated, we can go ahead and take one of the equations and move everything away from one of the variables, and that will isolate it. So in this case, I'm going to take the equation y minus 2x is equal to -3, and I'm going to isolate y. So in order to do that, I'm going to add 2x to both sides, and I end up with y equals 2x minus 3. Now it's isolated. Now I can go ahead and plug it into the other equation. So I have x plus y equals 6. But y is really equal to 2x minus 3. So I'm going to plug that in for y. So now it says x plus 2x minus 3 is equal to 6. Now I can go ahead and solve. So I'm going to combine like terms. So x plus 2x is 3x. So I get 3x minus 3 is equal to 6. I'm going to add 3 to both sides to get rid of this. So I get 3x is equal to 6 plus 3 is 9. Now I'm going to divide both sides by 3 to get rid of this 3. And I get 9 divided by 3 is 3. So x equals 3. Then I plug it into the other equation and solve. So I'm going to pick either equation, doesn't matter which one. I'll pick this one. And I'm going to plug 3 in for x. So I get 3 plus y is equal to 6. Subtract 3 from both sides to get y by itself. And I get 6 minus 3 is 3. So x is 3 and y is 3. Now let's talk about how we can solve this without having to graph. So if we're given something like this, 3x minus 2y is equal to 24 and 3x plus 2y is equal to 12, we're going to go ahead and solve this using what we call elimination. So here are the steps. First step is we're going to check for opposite x values or y values. Now opposites mean they have the same integer but with opposite signs. So for instance, we have a positive 3 and a positive 3. Those are not opposites. We have a negative 2 and a positive 2. Those are opposites. So these two represent opposites. So if we have opposite x or y values, we're going to go ahead and add the equations together. So we're going to add the entire equation. So we'll add these up. So we add 3x plus 3x, and we get 6x. Negative 2y and 2y is equal to 0, right? So that's the elimination part. We eliminated the y's. And then 12 plus 24 is 36. So we end up with 3x is equal to 36. Now we're going to solve for x. So 6 is being multiplied by x, so I undo it by dividing. So we divide both sides by 6, and we get x is equal to 36 divided by 6 is 6. So that's x. Now we know the x coordinate of where they cross, but now we need to get the y coordinate. So we're going to plug 6 in for x into one of the two equations. It doesn't matter which equation you pick as long as you plug in x as being 6. So we'll go ahead and pick this one. We'll pick the first one. And we're going to plug 6 in where x is. So instead of being 3x minus 2y is equal to 24, it's going to be 3 times 6 minus 2y is equal to 24. So 3 times 6 is 18. So we get 18 minus 2y is equal to 24. We need to get rid of this 18. So we're going to subtract 18 to get rid of that. And we're left with negative 2y is equal to 24 minus 18 is 6. We'll divide both sides by negative 2, and we get y is equal to negative 3. Now let's take a look at another example. So we're going to check for opposite x values or y values. So we have a positive 1 and a negative 2. Well, they have opposite signs but not opposite values. We have a negative 1 and a negative 1. So again, we don't have opposite values. So if we don't have opposite values, we're in trouble. So what we need to do is we need to create opposite values. We need to multiply either one or both of the equations by some number to get opposite values. So in this case, the easiest looks like it might be the y's, because we could just multiply one of these by a negative 1, and that gives us a positive y and a negative y. But we could also do the x's. We could multiply this whole thing by 2. That gives us a positive 2x and a negative 2x. But we're going to go ahead and do the top one by negative 1. If we multiply the top one by negative 1, we get positive y and negative y. Now, here's the deal. Anytime we multiply this, we have to multiply everything. So that's the x's, the y's, and the constants. Everything's got to get multiplied. So when we do that, we get negative 1 times x is negative x. Negative 1 times negative y is positive y. And negative 1 times 11 is negative 11. So what we're left with now is negative x plus y is equal to negative 11. And the bottom one didn't change. So now, notice we have opposite x and y values. So now we just follow the steps we did previously. So then we're going to add the equations together. And we get negative x and negative 2x is negative 3x. These cancel out. And we get negative 11 plus negative 19 is negative 30. So we have negative 3x is equal to negative 30. Now we just solve. So we divide both sides by negative 3. And we get x is equal to negative 30 divided by negative 3 is positive 10. So there's our x value. Now we're going to plug that in to one of the equations and solve for the y value. So I'm going to go ahead and use my new equation. I can use the new equation or any of the two that I started with. I'm going to just use the new equation. That's fine. So I'm going to plug 10 in for x. So this is negative 10 plus y is equal to negative 11. I add 10 to both sides to get y by itself. And I get y is equal to negative 11 plus 10 is negative 1. So y is negative 1 and x is 10. Let's look at another example. We have 5x plus y is equal to 9 and 10x minus 7y is equal to negative 18. So again, check for opposites. Well, 5 and 10 are not opposites, and 1 and negative 7 are not opposites. So I need to create opposites. So I could multiply this one here by negative 2. That would give me negative 10x and 10x. Or I could multiply it by 7, and that would give me 7y and negative 7y. I usually want to multiply by the smaller number because it keeps everything a little easier to manage. But it doesn't matter either way. This time I'm going to multiply by negative 2. So I get negative 2 times 5x is negative 10x, negative 2 times y is negative 2y, and negative 2 times 9 is negative 18. So now I have negative 10x minus 2y is equal to negative 18, and the bottom one just drops down, so I have 10x minus 7y is equal to negative 18. And now I have opposite x values, so I can go ahead and add the equations. These will cancel out. I'm left with negative 2y plus negative 7y is negative 9y, and negative 18 plus negative 18 is negative 36. So now I just need to solve for the variable. So I'm going to divide both sides by negative 9, and I get y is equal to negative 36 divided by negative 9 is positive 4. So that's my y value. Now I need to plug it into one of the equations to solve for the x value. So I'll use 5x plus y is equal to 9. And I'm going to plug 4 in for y. So now this says 5x plus 4 is equal to 9. Well, now I need to solve for x. So I'm going to subtract 4 from both sides. And I get 5x is equal to 9 minus 4 is 5. Divide both sides by 5. And I get x is equal to 1. Now let's take a look at another example. This time, though, we're going to notice something's a little different than the last one. So it says 5x plus 4y is equal to negative 30, and 3x minus 9y is equal to negative 18. So we begin, like always, by checking for opposite x values or y values. So 5 and 3 are not opposites, and 4 and 9 are not opposites. So we're going to have to create opposite x or y values by multiplying. Now on all the previous ones, one of the coefficients was a factor of one of the other coefficients. So we were able to just multiply one of the equations. Now what we should notice though is I can't multiply 3 by anything to get 5. And I can't multiply 4 by anything to get 9. So I'm actually going to have to multiply both of the equations now. So I can pick either the x values or y values. Now the y values are going to get really large if I start multiplying by 9. So I'm going to use my x values. And I'm going to multiply the top one by negative 3. That'll give me negative 15. And the bottom one by 5, which gives me positive 15. So now we have a negative 15x and a positive 15x. And then we're going to multiply that times everything here. So negative 3 times 5x, and negative 3 times 4y, and negative 3 times negative 30. And then I'm going to do the same thing on the bottom. So 5 times 3x, and 5 times negative 9y, and 5 times negative 18. And when I do that, I end up with negative 15x minus 12y is equal to 90, and 15x minus 45y is equal to negative 90. Now notice I have opposites, so now I can go ahead and add the equations. My x's will drop out. I end up with negative 12y plus negative 45y is negative 57y. And then I have 90 and negative 90, which is 0. So I'm left with negative 57y is equal to 0. I divide both sides by negative 57 to solve for the variable, and I get y is equal to 0. Now I'm just going to plug that back into one of the equations and solve for x. So it doesn't matter, I can use any of the 4 equations now that I created. So I'm just going to use this one. So I have 3x minus 9y is equal to negative 18, but y is equal to 0. So I plug that in. Now I have 3x minus 9 times 0, which is just 0, is equal to negative 18. So this just drops out. I'm left with 3x is equal to negative 18. Divide both sides by 3, and I get x is equal to negative 18 divided by 3 is negative 6. Let's look at another example. We have 3x minus 2y is equal to 2, and 5x minus 5y is equal to 10. So again, I'm going to check for opposite x or y values. 3 and 5 are not opposites, and negative 2 and negative 5 are not opposites. So I need to create opposite values. Again, I can pick the x's or the y's, it doesn't matter. I'm going to go ahead and choose my x values. So I'm going to multiply this one by negative 5, and this one here by 3. So that gives me negative 15x and positive 15x. Now I can just go ahead and multiply. When I multiply this out, I end up with negative 15x plus 10y is equal to negative 10. And when I multiply this one out, I end up with 15x minus 15y is equal to 30. Now I have opposites, so I can just go ahead and add them. The x's cancel out, and I'm left with 10y plus negative 15y, which is negative 5y. And negative 10 plus 30 is 20. So I'm left with negative 5y is equal to 20. I'm going to solve, divide both sides by negative 5, and I get y is equal to 20 divided by negative 5 is negative 4. Then I'm going to plug that into one of the equations and solve for x. So I'll pick 3x minus 2y is equal to 2. I'm going to plug negative 4 in for y. Then we'll combine these, so we have negative 2 times negative 4 is positive 8. So we get 3x plus 8 is equal to 2. Subtract 8 from both sides. And we're left with 3x is equal to 2 minus 8 is negative 6. Divide both sides by 3, and we get x is equal to negative 6 divided by 3 is negative 2. Now there's a video here that shows you how to check systems of linear equations in Desmos. So go ahead and watch that video. Let's talk now about how we can use Desmos to check our work when dealing with systems of linear equations. So first thing we're going to do is go to desmos.com, which is here, and we're going to click on Graphing Calculator. Now, this allows us to type in our equations over here. So let's go ahead and put in an equation. So let's say it's y equals 2x minus 4. So there's our first equation. Now we're going to type in our second equation. So we're going to go to the line below it. And let's say it's y equals negative 2x plus 4. So there's my two lines. And if I go to where the two lines intersect and click on it, I can see that it gives me the coordinates of exactly where the two lines intersect. They intersect at x equals 2 and y equals 0. So this would be the solution to my system of equations. And I can do this by inputting any two equations and then going to the point of intersection and clicking on it. It will tell me what the coordinate of that is, with the x coordinate first and the y coordinate second. So this is how you can check your work using Desmos when dealing with systems of linear equations. Let's take a look at how we graph linear inequalities. Let's look at our rules first. So first, we graph the function just like it was an equal sign. So we plot the y-intercept, use the slope to plot the second point. Then we need to decide what kind of line we need to use. So if they add something extra, they add the bar underneath, we add something extra as well and close the line. If they don't add anything extra, just like this, we don't add anything extra either, and we leave it as an open line. Then we need to decide which side to shade. If it's a greater than symbol, we should shade above the line. If it's a less than symbol, we should shade below the line. Well, with inequalities, we're going to graph them the same way. So just like we did before, we're going to plot the y-intercept, which in this case is negative 2, so I go down 2 and plot that point. Then I use the slope to plot the second point. Well, this is change in y, so we're going up 1 to the right 2. So we go up 1 to the right 2, plot my point, connect the dots, and now I have my line. Now the difference is we're going to shade where the y values are bigger than the line. So I'm going to look at the y-axis here, and I'm going to see where the line crosses, which is here, and I want all the y's that are bigger than that line. Well, they're all up here, so I'm going to shade that area up there above the line. So the shading is a new aspect of graphing that we need to consider. The other part is what kind of line to use. So similar to before where we talked about the open circle versus closed circle, same thing here. Every inequality gets a dotted line or an open line. Notice there, it's open because there's little spaces in between. So every inequality gets an open line or a dotted line. If they add more to the inequality, we do too, meaning if they add the bar underneath, then we're going to add to it and make it a solid line. So in this case, we have y is less than x. Well, I'm looking if they added anything extra, meaning that, did they add the bar here? If they didn't, which in this case they didn't, we'll leave it as it is and it stays as a dotted line. Now, here's an example of x is greater than or equal to 2. Now, they did add something extra. They added the bar here. So we'll add to it as well, and we'll make this a solid line or a closed line. So how does that apply to our inequalities? Well, when we graph these, we have y is less than 3/2 x. So we're going to plot the y-intercept first. Notice there is none listed here, so our y-intercept is 0. So I'm going to go here to 0 and plot my point. And my slope is 3/2, so I'm going to go up 3 to the right 2. So I go up 3 to the right 2, plot my point, And normally, I would just connect the dots. But I need to check to make sure I have the correct line, which in this case, they didn't add anything extra, so I don't either, so it should be a dotted line. So there's my dotted line. Now, I just need to shade it. So it says y is smaller than the line, so I'm going to go along my y-axis and find where it meets the line, which is here. And I want all the y's that are smaller. All of those are down here, so I'm going to shade everything on this side of the line. Let's look at another example. We have y is less than or equal to negative x minus 3. So again, I'm going to plot my y-intercept first, which is negative 3. So I go down 3 here. And my slope is just negative x, which really is negative 1. So that's negative 1 over 1. So that means I'm going to go down 1 to the right 1 and plot that point. Again, normally I just connect the dots, but I need to make sure I have the correct line. Well, they did add something extra, so we will too. So we're going to have a solid line. And now we just need to shade the graph. It says y is smaller than the line. So I'm going to go along my y-axis and find where they meet, which is here. And I'm going to look at all the y's that are smaller than the line, which are down here. So I'm going to go ahead and shade this area here. And that's how I graph the linear inequality. There's a video here that shows you how to check your work using Desmos after you've already graphed the linear inequality, so you can check it using Desmos. Let's talk now about how to check our work using Desmos when working with linear inequalities. So we're going to let Desmos graph linear inequalities for us so that we can check that against the work that we've done on our activities. So we're going to go to desmos.com and we're going to click on Graphing Calculator. And now we're going to go ahead and enter the inequality that we want to graph. So let's say it's y. Now to do the inequality symbols, we'll go down here to where it says keypad and click there. And here's all your inequality symbols. So let's say it's greater than or equal to. And then we can put in 3/2 x minus 5. And now it graphed the inequality for us. It shows the type of line right here and the shading. Now if it wasn't or equal to, we can see that it creates a dotted line, so it will create the correct type of line and it will show the shading of where the shading should occur. So that's how you can use Desmos to check your work when dealing with linear inequalities. Now let's talk about how to graph a system of inequalities. So we're going to graph it just like we did the system of equations. So we're graphing both of them at the same time, and then we're going to find the overlap of the shading. So the first one says y is greater than or equal to negative 2/5 x plus 4. So we'll go ahead and plot our y-intercept first. Our y-intercept is at 4, so we're going to go ahead and plot that point. Our slope is negative 2/5, so we're going to go down 2 to the right 5 and plot our point. And they added something extra, so we will too, so we should have a closed line. And it's greater than, so we should shade above. So there's our first one. Then we'll do our second one. Our second one says y is greater than 5x plus 2. So our y-intercept is 2, so we're going to go ahead and plot that point at 2. And our slope is 5, so we're going to go up 5 to the right 1, right there. They did not add anything extra, so we won't either, so it'll be an open line. And it's greater than, so we'll shade above the line, so we'll shade just like this. And what we should notice is we have a blue area, we have a red area, and then we have this purple area. The purple area is the only area that actually matters. That is the part that is the overlap or the intersection. This is the only part that applies to both inequalities. Let's look at another example. We have y is greater than or equal to negative 2/3 x plus 3, and y is less than 3x minus 1. So we're going to plot the first one. So we'll plot our y-intercept at 3, so right there. And our slope is negative 2/3, so we'll go down 2 to the right 3. They added something extra, so we will too, and have a closed line. And it's a greater than symbol, so we're going to shade above. So there's our first one. Now the second one says y is less than 3x minus 1. So we'll go ahead and plot our y-intercept at negative 1. And our slope is 3, so we'll go up 1, 2, 3, to the right 1. They didn't add anything extra, so we won't either. So it'll be an open line. And it's a less than symbol, so we'll shade below. So it'll be here. Again, we have a blue area, we have a red area, and we have a purple area. The purple area is the area that matters. That is the overlap of the two inequalities. So get one more example. We have y is greater than or equal to negative 2x minus 3, and y is less than x. So we'll go ahead and plot the first one. So our y-intercept is at negative 3, so we'll go ahead and plot our point there. And then our slope is negative 2, so we'll go down 2 to the right 1 and plot our point. They did add something extra, so we will too. So we'll go ahead and have a closed line. And it's greater than, so we should shade above, so that's over here. So all of that should be blue. Now our second one, y is less than x. So there is no y-intercept, so it's really at 0. And our slope here is really 1, so we'll go up 1 to the right 1, plot our point. They didn't add anything extra, so we won't either, so it'll have an open line. And it's a less than symbol, so we'll shade below. So we shade down here, and we have our blue area, our red area, and our purple area, and the purple area is the intersection of the two inequalities. There's a video here that shows you how to graph systems of linear inequalities in Desmos. So go ahead and watch this video. Let's talk now about how we can use Desmos to check our work when dealing with systems of linear inequalities. First thing we're going to do is go to desmos.com, which is here, and then we're going to go to where it says Graphing Calculator. I'm going to click on that. And on the left side, I can enter the two inequalities that I want to look at. So let's go ahead and put one in. Y is greater than 1/2 x minus 5. So there's my first one. And then I'm going to put my second one in. Y is less than 3x plus 2. Okay, and now we can see where we have our two lines that are drawn. They're both, in this case, dotted. Okay, but that could change depending on the sign. They're both dotted, and we can see that this area up here is all shaded in red. This area here is all shaded in blue, and this area is shaded in purple. The purple area is the part we care about. This is the overlap of the shading. So all of this area here would represent the solutions to the system of inequalities. So, and we can enter this in with any equations, any inequalities, and it will graph it for us and show us exactly where the solution should occur. So that's how you can use Desmos to check your work when dealing with systems of linear inequalities. Let's take a look now at the Systems of Linear Equations and Inequalities Review Part 2 assignment. The assignment begins with the learning goals and success criteria. If we scroll down, we can see the questions. So we're going to solve using elimination, and it says to check your work using Desmos. So we have opposite coefficients here, so we know our x's are going to cancel. And we have negative 2y plus 8y is 6y. And negative 12 plus negative 24 is negative 36. So 6y is equal to negative 36. So we divide both sides by 6, we get y is equal to negative 6. So this one's not going to be the correct answer because it says y equals 6. This one says y equals 6, so it's got to be this one here. We can check it to make sure that it's not no solutions, but when we plug it back in, we'll see that this is the correct answer. So we'll do that for each of these. We'll answer each of the questions, and all of them should already have opposite coefficients, so that's okay. You'll just go ahead and work through each of these questions until you get to the end. Once you get to the end, you'll click Next. This will take you to your Before You Go. Go ahead and fill out your Before You Go, and then submit your work on Google Classroom.